joining. We are, I don't know, 3 weeks into July right now, which feels wild. I can't believe we're there already, but we are. It's nice to see you all again. Every time we meet, I feel like it's been a really long time since the last time we've seen each other, but I suppose it hasn't been that long. We do have some new faces tonight, including Brian Grant, who is our presenter. And I will do a little bit of an introduction before we get started there. But before we jump into kind of the meat of the presentation, I'll just do our standard intro, introduce everybody to who we are and what we do. And then we will open up the floor for a couple of different announcements. So if you would like to promote any events, we'll open up the floor for that. And then if you are either looking for a job opportunity or promoting a job opportunity because you're hiring, I welcome you to speak up there as well. One other just quick thing to notice, we are typically really active in the chat here in this group, so feel free to ask any questions in the chat throughout the presentation. I will keep an eye on them, and then we can get them back over to Brian either during or after the presentation, whatever you prefer, Brian.
Either way is fine. I think it'll probably, depending on the question, it'll make sense. So I'll leave it to your discretion.
Okay, cool. All right, so I have just a couple of quick slides that may or may not advance to the next slide, depending on my computer. Okay, so just very quickly, who are we? What is this group? Our group, the Power BI DC user group, is 3.5 years old, and as of this week, we reached over 1,000 members in our group. So I just want to take a minute and celebrate that. That is really huge. So our success is because of each of you, and I want to say thank you to everybody who has ever attended or participated or volunteered. I just am super proud of that milestone, and I really appreciate everyone's participation. I know there are lots of faces on the line that we know and see regularly, so thank you all for coming back again and again and spending your time with us. This is the highlight of what I do. I love this group, so thanks for being here. So we are just a group of folks that love data, and we talk specifically about the Power Platform, and then within that specifically about Power BI. But if you have any questions about any of that as we go, you're welcome to drop them into the chat, and someone in the group will answer you, guaranteed. So we are a volunteer-run group. We want to make sure that everyone feels like this is a safe space. There are no dumb questions. You can ask anything. If you have specific questions that have been plaguing you at work that you'd love to get an answer to, we can stay on the line after Brian's presentation and chat. I am always fighting with my computer, every single meeting. That is not different. I'm trying to advance to the next slide.
What's a meeting without some AV issues?
Come on. Okay, there we go. So what is... This is apparently my first day ever presenting. So what is the PUG? The Power BI user group? We're a part of the Global Power Platform User Group Network. It is now run and managed by Microsoft on the community website. So the Power BI specific one is community.powerbi.com. You'll find a page for our group there, but we're actually in the process of shifting over to that site. And so you will be able to continue to find most of our information on the meetup page. That's where we have everything posted for now. And hopefully as we move forward into the future, we'll get fully migrated onto that Microsoft site. Jamie, funny. This is my work computer. That's the funny thing. Okay. All right, so what is the Power Platform? If anyone is brand new to this space, I would assume you all know at least a little bit about it, seeing as though you showed up for a presentation specifically about DAX. But if you think maybe DAX is a person, I'm not sure, I'll just introduce you to the Power Platform. So this is Microsoft's low-code, no-code development environment for developing solutions, so applications using Power BI, automating processes using Power Automate, looking at the results of that and discovering insights in Power BI, and then fancy chatbots that are really easy to configure using Power Virtual Agents. There's a whole infrastructure underneath that, and we're not going to go into that today, but just a primer for those of you that are seeing this for the first time. I have my eye on the chat, which is why I'm laughing. I'm not just laughing at myself. All right, so let's open up the floor for a moment. Is there anyone that is either looking for a job that wants to introduce themselves, or do we have any recruiters or any managers on the line that want to promote any hiring opportunities within your organization?
Yeah, this is Damu here. We have a data engineer role. If anybody is looking for SQL development roles, we're looking for it. So I'll put my email address in the chat window, and you can reach out to me.
Fantastic. And good to see you again. I think it's been like over 2 years now since we met, but nice to have you here. Anyone else?
I'll just put it in the chat. AIS is always looking for good people, anything related to Power Platform, but especially Power BI. So I'll post a link.
Thanks, Jamie.
And ping me if you want to ask questions about working here. Happy to answer anything.
Great. Thank you so much. Anyone else? Everyone on the line is gainfully employed, which is fantastic. If you're not, talk to Jamie or Damu. And upcoming events. This is another one where I would love your input. The first thing I wanted to announce is just we've got a Power Platform user group in-person event coming up in August, which is super exciting. And thanks, Jamie, for putting the link in the chat there. We also have the DataViz DC group, which one of our members runs, and that the topic there is building custom DataViz using D3.js and intro to observable. So if anyone is interested in either of those events, I will drop the link for the latter in the chat as well. Anyone else on the line that wants to promote either in-person or virtual events that are coming up within the next month? Going once, going twice?
I'll just add that I'm one of the leaders of the DC Power Platform group, so we would love to have folks in the DC area come out and join us. I put the link in the chat, please check that out, and look forward to seeing everybody. And the only other thing I'll add is there's a great Power BI user group out in Portland, Oregon. So depending on your time zone, you can check them out. I'll put a link to their group. They meet very regularly as well, so check it out.
We'll take that.
That was not planned, but it's true.
Shannon, did you want to put up the report that shows all the aggregated meetups? Do you still have that?
I don't have the link handy at the moment. Kevin, would you mind dropping it in the chat?
I just did.
On it. Oh, and you made a tiny URL for it. Thank you. So Kevin, do you want to tell us a little bit about this report?
Sure. This is it aggregates the different meetup groups that I have found by looking through meetup.com. It actually started with Alex Powers. Him and I join a group that we call Saturday Morning Learning. We have a bunch of people to get together before the guy in the cube stream. And he shared this with me. I picked it up and kind of ran with it and now made it a public report. Like I said, it aggregates out the different meetup groups and then shows on a calendar view the days that they're coming, or shows also in a list view that you could see all the different groups. If you know of a group I'm missing, just reach out to me, LinkedIn, Twitter, Kev Arnold, and I'll add it, and hopefully it helps everybody know what groups are coming.
Thank you so much, Kevin. I would also like to put in a little plug for the Saturday morning learning group that Kevin runs. I have not yet had a chance to attend, but they are super active and they post a lot on Twitter about what they're learning and what they're doing. So if you see that on Kevin's calendar and you're trying to learn Power BI, I would highly, highly recommend.
Yeah, like I said, we meet every Saturday before Guy in a Cube for about an hour. We do book reviews or book study groups and then just kind of random topics, and it is really good. So again, reach me on Twitter at Kev Arnold. I'll put that in the chat too.
Thank you. Thanks so much. All right, so one other upcoming event that I wanted to promote is that through a partnership between this group and the Microsoft Power BI community folks, we are running a webinar on Thursday, and it's going to be at 1 p.m. Eastern time, just for an hour. So it's a lunch hour type talk. And what we're going to do is we're going to run through some of the challenges from the Workout Wednesday initiative. For those of you who are not familiar with the Workout Wednesday initiative, it is just a weekly challenge that this lovely group of people presents, and we encourage you to build visualizations using Power BI with the goal of getting hands-on practice, building your portfolio, and learning great data viz design techniques. So if you are interested and you haven't heard of it and you'd like to join us, we're going to be doing a live build on Thursday. So I would encourage you all to join. Again, I'm not great at multitasking right now, but I will put all these links in the chat once Brian hops on. And then following that, so just the very next hour, there is a really interesting Power BI Dev Camp. This is a series that the Power BI community team puts on, but this one is about building multi-language reports in Power BI. I know that we in the DC area are very multilingual, and a lot of us work with clients that are based all over the world. And so I am super excited for this one. I think it's going to be great. So I just wanted to put in a plug for that as well. So those are both on Thursday and they're back to back. So one is 1 to 2, the other is 2 to 3.
Hey Shannon, there's a Power BI boot camp on this Friday too. So I'll put a link on the chat.
Oh, great. Thank you so much.
Yeah.
Power BI boot camp. Is that all day or?
Yeah, it is all day. Back-to-back sessions, like almost like starting at 11 a.m. to all the way to 9 p.m., 10 p.m.
Amazing. Okay, awesome. So
Shannon,
if any of you...
Let me ask a crazy question here. How will we get this recording that you're doing right now?
Good question. We have a YouTube playlist, and I will also drop that link into the chat once I am able to multitask. And I usually post the recordings a couple of days after the meeting. And I will also post it in the comments of the meetup event. I don't really have a great system for it yet, to be honest.
That's good. That's good there. Thank you. I appreciate it.
Yeah, of course. Okay, one other thing I wanted to just plug really quickly. Jamie, you are so on top of things. Thank you. One other thing I wanted to plug quickly is I stumbled across recently, there is a collection of resources located on the Microsoft website, and it's just aka.ms/PBI training. And this is a collection of all of these in-a-day trainings. Now, the content here is twofold. You'll find instructor content. So if these are events that you would like to run, you can. And then you'll also find attendee content. And I wanted to throw this out there, number one, to share the resources. And then number two, to kind of informally poll the group and see if anyone would be interested in us putting one of these on. And it would be virtual for now. But you know, just to see, and what we can do is we can send out a survey or just do a quick poll on Twitter or something and see potentially which track you'd like to do. There varying levels of difficulty and skill are needed for each of them. So maybe we'll see which ones we can do. And actually, so Ben just mentioned in the chat, and so did Daryl, DAX in a day would be good. So maybe the DAX in a day would be a nice follow-up to Brian's presentation tonight. So awesome. Okay. All right. So I am putting that into the vault. The door's a little loose on the vault, but I'm putting it in there, and we will see if we can get that organized for one of our upcoming meetings. Excellent. I am trying to advance to the next slide, I assure you. Okay. All right, so now before I introduce Brian and turn it over to him, is there anyone that has anything else that they wanted to mention? Any other great resources they've come across, or anything you want to bring up before we jump into our featured presentation? All right, lots of activity in the chat. And as I will also collect all of the links from the chat, and we'll put those in the description of the video. So if anyone is looking to come back to these, I'll make sure that we have those all in one place. Okay, that's enough for me. With that being said, I am going to stop sharing, and I'm going to turn this over to Brian. Brian is a senior analytics consultant at CSG Pro. And I would highly recommend, if you have not seen any of Brian's content, of course, you're about to see it right now, but he has a ton of great videos out there. And so I would highly recommend that you check some of those out. I'm sure you'll be interested, especially after you see his presentation. So Brian, I'm going to let you introduce yourself, tell us a little bit more about yourself, and then take it away.
Sure, that sounds good. Thanks, Shannon. So my name's Brian Grant. I'm a senior consultant with CSG Pro out here in beautiful Portland, Oregon. And I do all things Power BI. So that includes data visualization. It includes the M language. And of course, it includes DAX, which is what we're going to be talking about today. So I've been working with DAX since before Power BI was a program, back when it was a plug-in to Excel. So I've been doing this for a long time, and I like teaching all things about Power BI. I like all the different layers, but DAX is kind of my favorite because, frankly, it's the hardest until it snaps with people, right? It's this language that is. I like to say that the hard things are easy, but unfortunately, the easy things are hard, right? So when you're just getting into it, it's very, very, very unintuitive. But occasionally, I'll have these moments with people where things just snap, and when they do, they go, "Oh, I kind of get it," and that really just makes all of it worth it. So without further ado, I'm going to go ahead and share my screen. Let's see. I'm also not really that great at self-promotion, to be honest. So like my intros are, they're okay. Hopefully, I think my content sort of makes up for it, though. Let's see. Come on. Where are we going? So let's share. Teams is being just a smidge slow today, but that's okay. I'm a smidge fast, so it kind of makes up for it. Somebody give me a shout if you can see my screen.
Yeah,
we can see it.
Oh, good.
Fabulous, fabulous, fabulous. Okay, so hey, welcome to my presentation, everybody. This is Seeing Inside DAX, Power BI's Advanced Calculation Language. And really, I could just title the whole thing, it's mostly just tables. Because the more you know about DAX, the more you will find out everything is tables. DAX is the language of tables, and I hope at the end of this presentation, you'll be convinced of that, at least in some small amount, okay? So, well, I just said, what is DAX? Well, let's go to a slide called What is DAX for a more formal introduction, shall we? Come on. I'm going to kill my webcam because everything's just running real slow on my machine at the moment.
Okay, yeah, I was having the same problem.
Okay, so hey, what is DAX? DAX is a querying language that builds summary tables on demand, right? Well, what do we mean by that, right? It's accurate, but like it's not super meaningful. Well, you use the M language, which is really just Power Query, which is this, Power Query editor or get data button, to go reach out to different data sources like Excel or SQL Server or Access or a Wikipedia article, wherever. Grab data from a bunch of places, clean it up, and load it in a detailed form into your data model. Data model is the stuff sort of over here. That's the raw data that you load to summarize, right? Now, once you've loaded that raw data, the job of the DAX engine is to summarize it on demand very, very quickly. So here, sort of in my example, I've got like a sales table with 13 million rows of data, maybe a products table with a couple thousand products, maybe a couple hundred stores. The job of the DAX engine is to create summaries of this data incredibly quickly, right? What do I mean by a summary table? Well, it looks something like this here, right? This is detailed information, 13 million rows, every single product, every single store. End users don't want to see that. They want to see something like, show me total sales by store, city, and product category. That kind of a summarization. Now, what do we mean by on demand? Well, if I click on this slicer down here, I go from looking at regular products to premium products. If I uncheck it, I go to looking at everything. So every single time I click on one of these checkboxes, which is to say every single time I interact with the report, DAX is re-summarizing my data. So all 13 million rows get re-summarized about that quickly. Very, very, very fast. Okay. So how does this fit into Power BI? Click. And hey, there we go. So the idea is that DAX is the piece of Power BI that creates summarizations that the Power BI rendering engine then draws as a visual, right? So we start again by getting our source data. Maybe it's in SQL, maybe it's an Excel file. It's probably in Access, even though it shouldn't be. It's somewhere. You use that Power Query or M engine to go load data into your data model. You do that every single night. You get this detailed information, 13 million, sales transactions, 8,000 products, I don't know, 2,000 days in your calendar. And then your DAX engine is in charge of summarizing that data, creating a table of numbers that Power BI can then draw as a visual, right? So every time you have a Power BI visual, it is a rendering of a summary table produced by the DAX engine, right? So every time I interact with the report, right, DAX re-summarizes the data, and then Power BI can draw it as that new selection, right? So if I say I want to look at beverages, right, Power BI, I should say DAX, re-summarizes that data, sends the result to Power BI, which can then redraw the visual. Okay, very, very fast. Now, you may be asking yourself, this sounds, actually, you're not asking yourself, you're stating to yourself that this sounds like a pivot table, right? This whole thing of like on-demand summarizations. Yeah, in fact, DAX used to be sort of belong to Power Pivot. That's the old Excel product that it belonged to. In fact, it's still there. So the idea is that this is sort of designed to be a pivot table 2.0, right? Pivot tables, but better, right? So with a pivot table, you also, in an Excel range, have a whole bunch of data, no more than a million rows, because that's all it'll hold. But you've got a whole lot of detailed data. And then you create a pivot table, and it gives you these pivot table controls, and you drag stuff into the pivot table controls, and it re-pivots or summarizes your data. So DAX is designed to do the exact same thing, except it can work on much larger sets of data. So not a million rows, but maybe 100 million rows. And it can work with multiple tables, and it can handle complex calculations, things like year-over-year growth, things like that, right? Now, the code in DAX and Excel look alike. They're designed to. It's designed to be friendly to people who are coming from Excel. But do not get fooled. The DAX language is very, very, very different than Excel, right? Excel thinks in cells. DAX thinks in tables. Okay. More on that in a minute. Okay, so let's pop back to summary tables just so we can drive this point home, right? So for every single visualization in Power BI, right? Every time you open up a Power BI report and you see visuals, right? Every single one of those visuals has a DAX summary table behind it. A summarization of raw data, a summarization of detailed data that is drawn as any number of visuals. So if you've got a visual like this, where we've got sales over time, where we have total sales broken down by year and quarter, well, in order to draw this line chart, DAX produces a summary table that looks like this, that has total sales broken down by year and quarter. So this is just a rendering of this right here, right? If I've got total sales broken down by my city and also my category, whether it's beverage or food, well, in order to draw this stacked column chart, Power BI is going to need a summary table that looks something like this over here, with total sales broken down by city and category. Even real simple cards. If I've got a card that says, what is total sales? Well, Power BI is going to need a summary table that has that number, what is total sales, that it uses to draw this over here, right? And every time I interact with my report, right, Power BI issues new summary queries, new requests to summarize data. DAX receives those and then re-summarizes the data based on this user selection. So when I click on 2017, Power BI says, oh yeah, I need new summaries of data in order to draw these. It sends off some request to DAX that says, re-summarize that data, but this time add a filter for 2017. DAX says, you got it. And in less than a second, you get new summaries looking at just 2017, or maybe just our sit-down stores, right? And then Power BI can take those summary tables and draw them as the visuals over here, right? Now, I will pause for a second. I say here summary tables approximated with table visuals. Technically, this is a table visual, and by that I mean, if I click on it, this is actually this visual right here, right? So technically, this is a summary table drawn as a table visual, okay? So behind the scenes, there's a table that gets sent to Power BI to get drawn that looks like this without all the bells and whistles, without information on fonts and colors and things like that. But the table visual is a very good way to see or approximate a summary table, which is frankly why if you ever get stuck on a DAX measure, right, and you're trying to do it in a visual that looks like this, one of the first things I always recommend is to convert it to a table, because you'll get a much closer approximation of what the actual summarization is that's getting sent back from the DAX engine. Okay, I'll pause for a second. I tend to talk kind of quickly. Any questions about what we've talked about so far? Anybody love my choice of font? I think it was just the default font.
I don't see any specific questions in the chat yet. Does anybody want to come off mute and ask a question?
I can ask a question.
Sure.
So with this Power BI, so from my understanding, you can connect the Power BI to say, if you have like, let's say millions of rows of sales data and say a Microsoft SQL server, you can connect the Power BI to that and then harvest your data from that table. I was wondering whether it's possible, like, let's say if your enterprise uses a lot of Oracle, like Hyperion or any Oracle products, whether it's possible to attach Power BI to forward data from the Oracle database into the Power BI.
Yeah, absolutely. Yes, that's absolutely possible. So I don't do that a ton, but the idea is, so I'll step back here for a second. I'm going to jump back here to, no, not that one. This guy right here, right? So DAX summarizes physical tables that you load with this Power Query engine right here. What do they call this thing? I say that they change the name of these buttons all the time. That's not actually true. I'm just stuck using the name from like a decade ago. I guess they call it transform data. I think they used to call it get data, right? So this button, this is basically connects you to the M engine, which is different than the DAX engine. So the M engine's job is to go reach out to different source systems like SQL Server or like Oracle or Access or some API endpoint. And it lets you connect to a ton of different systems. Then you could go clean up the data, and when you load it into the data model, right? So the data model is, let me zoom out a little bit here, right, is the data that's been loaded and cleaned up, right? So this is the data that is ready to be summarized. So in terms of loading it, there's a ton of different sources that you can use to get it. So if I go to here, get data, and click on more, right, what you'll see here in a second, I hope, is a list of all the connectors that you could use to go get this data, include like Oracle database and other things like that. So once you load and clean up that data, DAX actually, it doesn't know that it came from somewhere. It has no idea what the source of the data was, because the job of the M engine is to get it, clean it up, and present it to DAX in the same format very consistently. I'm not sure if I answered your question or if I dodged it, but I think I did it with good gusto. How did I do? Does that sort of answer your question, or is it?
It sure did.
Fabulous, 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 fabulous. Okay.
I have a question too.
Yeah, sure. What you got?
Yeah, so when you're summarizing, do you have a preference in your calculation, either by row context or by column when you're doing your summations?
So we'll say more. Give me an example.
So you have your summary tables here.
Right.
And I'm wondering whether the calculations that you're summarizing here have been calculated via row context or by column, the sales column. And if you have a preference for either, what will that be?
So I may punt a little bit and answer that later, because I want to make sure I get the context of it. But let me say it this way, right? So the row context of each one of these rows provides information about, how to perform the aggregation, right? I would generally say that what I like to do is store, and what I think is the best practice is to store the data in as detailed of a format as possible and do as little of the calculations while loading the data. And then you use measures to aggregate it. And I think maybe I'm getting closer to the question. I generally think that if you have like a classic example maybe is I've got a sales transaction table that has both units and price per unit, right? Should I create a sales column that is just one multiplied by the other, right? Yeah, Roche's maximum, exactly, right? So in general, for smaller models, I prefer to actually sort of load a fair number of columns, mainly because, not that it runs faster, it doesn't, but with a small model, I'm less concerned about performance because it's small, and I'm more concerned with, I'm a consultant, so when I'm done, I hand this thing off to somebody. I want it to be easy to understand. So with a very small model, I tend to produce a lot of sort of almost not quite pre-aggregated columns, but ones that reduce the amount of algebra required to perform aggregations. Once you get up into medium and large size models, however, it makes a lot more sense to do all of that in measure. So if you've got the number of units sold and a price per unit, don't add a sales column because you can always get that by multiplying one by the other. Again, I'm not sure if I answered your question, but I answered a question. Was that approximately close or good enough? Maybe till the Q&A session?
Till later, yes.
Okay, fabulous. Okay, so every single visual in Power BI is a rendering of a summary table. DAX is in charge of creating these summary tables. If it's not immediately obvious, and it might not be, every single shape in a Power BI visual corresponds to a row in a summary table. So if I've got this right here where I've got my $33 million in sales for Oregon Beverages, well, that is the result of pulling this number from this row right here, right? So anytime you see a shape on a visual, like maybe food sales for Washington State, right? Well, you got 5 million for Washington State in food, right? Well, that's right there. So the idea is these summary tables essentially serve up numbers and categories that make it very, very easy to draw the visuals. Okay, so let's talk for a second. So we've got our summary tables, right? This is what gets drawn as a visual by the Power BI rendering engine. What are the actual, how do you get those tables? And the answer is summary queries, right? So summary query is just my name for a DAX query. So when you write a query in the DAX language, I refer to it as a summary query because when you write DAX, you're almost always summarizing data, right? You could do other things with it, but you generally don't. It's optimized for that exact kind of task, okay? So let's say that we've got a visual down here, right? We created this visual. The way we did it is we created this little sort of clustered column chart, and we dragged state onto the axis, and category onto the legend, and total sales onto values, and we get the thing that we want, right? But how do we get this? Well, when I click over here and sort of compose my visual, Power BI sees that and says, I need to create a visual of total sales broken down by category and state. In order to do that, I'm going to write a summary query that goes and gets me that summarization. So it writes a DAX query that looks kind of like this, right? Where it says summarize columns. Go get me every combination of state and category, right? And for each one, I want you to create a column called total sales. And for every single one of those rows, I want you to go get the total sales calculation, right? So this summary query gets sent to the DAX engine. DAX says, I know exactly what to do with that. They want total sales broken down by state and category. And lickety split, it summarizes that data, right? And creates a summary table of total sales broken down by state and by category. It creates it and then sends it back to Power BI, and Power BI will then draw it as the actual visual. And every time you interact with the report, what's going to happen is Power BI is going to detect that and say, we need to re-summarize the data. So if I click on 2016, obviously, this should change right here because it should only be looking at 2016, right? Well, the way it works is when I click on 2016, boom, the summary query changes. See that dot there? That line just got added. The summary query added a filter for 2016. DAX saw that, right? Re-summarized the data, now just looking at 2016. That got sent to the visualization engine for rendering, and now the numbers are smaller. If I click on 2017, right, the filter changes to 2017. If I control click on 2018, right, I get a filter for 2017 and 2018. If I click on Oregon, right, it adds yet another filter, right? If I cross filter to interact, if I click on this little slice of the pie chart here to look at my walk-up stores, that also just adds another filter line to the summary query. So every time I interact, a new summary query gets built for every single visual, sent off to the DAX engine. DAX creates that summarization, sends it to Power BI, and then Power BI draws it. And if you click on enough of these guys, the chart gets kind of small and sad, right? So I'll pause. Any questions about that? Any questions about that? Obviously, if I turn these guys off, the summary query gets simpler and simpler. Okay.
No questions in the chat.
Fabulous, fabulous, fabulous. So let's talk for a minute about measures, right? So I see here that I've got my summarization, and I'm not a DAX expert by any stretch of the imagination. I mean, who is, right? But I kind of get, all right, yeah, summarize columns. So we want every combination of state and category. We want total sales for each one. But here it just says total sales. Like, how does it know to get these numbers? Well, that's where measures come in. This is a reference to a measure. So a measure is a set of preset instructions that can be used across a variety of visuals and hence summary tables, right? So if I've got two visuals over here where I've got my total sales broken down by state and layout, and then another visual I've got total sales broken down by my fiscal year, or I should say my calendar year, right? Well, the way it works is that I create a measure called total sales, and I say, I have some business question that I want to ask over and over, and I want to make sure that I ask it consistently, right? So after I create this measure called total sales, I give it a definition, and I say, this is the official formula for answering the question, what is total sales? Then when I use that measure in this summary table, right, I get a consistent calculation formula, and I could use it again in this summary table, right? And the numbers are different because I'm looking at years here and I'm looking at combinations of layout and state, but the formula is always very, very consistent. This is designed to avoid the Excel problem where you open up an Excel report and on 5 different pages, the same calculation is being done 5 different ways. This is here to enforce consistency. So if I go back, so if I've got a measure like total sales, it's going to run this formula right there, right, for whatever combination of categories that I provided here, right? So I can run it for total sales for state and category or by year or by, I don't know, product manufacturer, whatever I want, but it's always the exact same formula. Pause real quick. Anybody want to jump in for questions? Going once, going twice, 3 times sold. Okay, so Brian, that's great. I don't want to do that. That sounds awful. I don't want to do any of that stuff, right? All right, let me convince you a little bit more, right? So if you learn to write DAX, you can perform some more complex dynamic calculations that are trickier to do other places. So you could do things like simple ratios, like a margin percentage or a shipping cost percentage. You could do things like goal to actual variances, year, quarter, month to date type sales, rolling 52-week window kind of sales, year over year calculations, returning customers, new customers, lost customers, dynamic sales ranking, all kinds of what if scenario analysis. DAX unlocks a lot of advanced calculations that you can't do without measures. And now without measures, you can do very simple aggregations, sums, averages, mins, maxes. But the minute you want to do something more complex, you're going to have to start using DAX. And frankly, if you're going to be using Power BI a lot, I really recommend learning DAX because it helps you understand how to do this complex stuff. And when a person asks you, like, hey, why is this calculating incorrectly? You don't just shrug your shoulders. You actually have a sense of how the stuff works. Brian, I'm not convinced by this slide. I still think this is terrible and I don't want to do it. All of this sounds horribly annoying. I'm pretty good at SQL. I'm pretty good at Excel. I'm pretty good at Power Query. What I'll do is I'll just preload the calculations into a column ahead of time, right? So, hey, look, I've got my stores table where I've got all my different stores, right? And you know what? Somebody asked me to see the distinct customers for each one of my stores. So I use some SQL or Excel. It'd be actually pretty hard Excel, or some Power Query. I've done it, but it's hard to create a distinct customers column here in this table. And I can see my distinct customers for all my different stores. Now, if all you want to do is report at the store level, this works fine, right? The minute you want to slice and dice or aggregate, this falls apart. Why does it fall apart, right? Well, if I take this column here and drag it into like a matrix visual, where we're breaking down distinct customers by both location and state, what you'll find is you could do a simple sum, but a simple sum is not correct, right? Because if you look, this is distinct customers, right? If I add up all these numbers, that's assuming that every single customer only goes to one store, and that's not actually correct, right? So here, if we add all these up, it'll tell us that we have 23,336 distinct customers, but we don't, right? If I use DAX, I could correctly identify that a bunch of customers go to both the Beaverton store and the Pearl District store, right? And therefore, when I roll these up, it's not 17,000, it's 10,000. Look, if we look at the correct distinct customers, it's less than half. So when you need that kind of dynamic calculation, you kind of have to do it in DAX. Furthermore, if I click on different slicers, like I click on 2016, right? Well, if I use SQL to load this, these are just numbers once it's been loaded. If I use DAX, these can be calculated on demand. So when I click on 2017, these numbers stay the same because they're preloaded, pre-aggregated. These are always dynamic, so it gives me a lot of control to do very fancy stuff. Okay. All right, I think I've successfully convinced everybody that you should learn DAX. Pause for questions. Going once, going twice. All right. So, Brian, you've convinced me that I should learn DAX. However, there's a problem. I have heard from the title of this slide. The title of this slide told me that DAX is simple, but it is neither intuitive or transparent, right? So it's very simple once you understand it. The hard part is actually getting to understand it, right? So within DAX, there's only three main types of operations, and they interact in very, very consistent ways, absurdly consistent ways. The problem is it's very difficult to see what's happening, right? So it's a bit like trying to learn chess without being able to see a chessboard. You can only read the chess notation. Oh, where is my hat? That's a good, it doesn't fit with this new chair, which is kind of a bummer, right? So in order to understand DAX efficiently, it helps a lot to be able to see it. The problem is you can't see it. You can see the physical tables in your data model. So I could come over here, right? And I could see, you know, all 13 million rows. There they are, right? There they are. Fascinating, right? I can also see the measure definition, right? If I create a measure called total sales, I get to define what it is. I can even sort of use some trickery to go find the summary table. It's actually not that tricky. I just convert my visual into a table. But how do I get from here to there? Is it magic? Well, probably. Well, no, it's actually not, right? So what's in between? We've got our Power BI visuals. We've got our summary tables. We've got our physical tables, which are the things being summarized. We've got some measure definition and some summary query, but what goes in the middle? Well, unfortunately, or fortunately, it's more tables, right? So when I said DAX is the language of tables, I'm not kidding, right? In order to go from a physical table, which is sort of your raw data, to a summary table, which is your summarized data, there's a bunch of temp tables in the middle, right? So when you write DAX, what you're really doing is orchestrating temp tables. You are saying, I want to get these temp tables and use them for these purposes. So almost everything you do in DAX revolves around these temp tables. And I say temp tables because they're temporary, right? When you hit the save button on your file, they're not saved like a physical table is, right? They don't persist within a visual. They exist just long enough to go from here over to here, right? And one way you could describe DAX is the strategic procurement, manipulation, and application of temp tables. And if you could see them, they're a lot easier to think about and work with. Unfortunately, you can't. You can't see these things. All you can see is the code, okay? So the good news is there's just three basic kinds of things you could do with temp tables, right? Three basic operations, as I call them, right? There's something I call table derivations. These are the bits of code that create temp tables based on your physical tables over here. Maybe it's a subset of a row. Maybe it's all the distinct values in a column, right? There are filter revisers, which can take a table and add it as a filter. So if you've got a table for lunch and you want to add it as a filter, you could use a reviser to do that. And then there's iterators. These are the things that take temp tables and process them, right? Turn them into something useful. They might aggregate a temp table. They might reduce the number of rows in a temp table. Anytime you've got a temp table and you want to turn it into something else that isn't a filter, you use an iterator, okay? Now, if you haven't watched me a bunch before, these terms might seem completely new, and that's because I made them up, right? But I made them up strategically, right? This is all part of sort of what I refer to as the elements of DAX, right? So I've got a series on YouTube. I don't want to make this thing a plug for that series, but if you're wondering why are there these new terms out there, well, I created this mental framework is what I call it. It's a collection of terms and concepts and ideas that are designed to help you understand DAX faster. So it's sort of ways of providing a language to describe DAX, which hopefully makes DAX easier to learn and use. So it does things like it's going to categorize functions into sort of families of functions that are going to help you see patterns. It's going to rename some terms with some easier to understand, if a little bit less precise names, less technical names anyways. And it'll even hide a couple advanced concepts to make the overall learning easier. It's really designed to be a middle step for DAX, to help you go from like practical DAX that you can get in a whole lot of books to take be sort of a bridge that can get you towards some of the stuff that you'd see in SQL BI. Something in the middle designed to make it just a little bit easier, okay? So I talked about my 3 elements over here, right? Derivations, revisers, and iterators. I'm going to show you an image right now, not because I want you to memorize it. I don't, right? At the end of the Elements of DAX series, if you can kind of make sense of this thing, that's great. I don't care about that at this point. All I care about is you can see that these circles here, these are the elements. These are the main kinds of things that you have to memorize. You need to memorize these 3 things and how they interact with each other. And if you do that, basically at that point, you know DAX at an intermediate level, right? If you understand how to create a temp table, how to add it as a filter, and how to process it into a number or a smaller temp table, right? You know how to work with DAX. This is hard to look at for the first time on a slide, but you can at least see, I bet if you gave me a week or a month or a year to learn this thing, in fact, I wouldn't need a month or a year. I could probably do this in like a week or something like that, right? Just at least memorizing these basic concepts and the interactions between them, okay? That's sort of what we're going for. Okay, so but that's way too high level. Let me give you something a bit more concrete, Well, actually, I'll pause before I jump into kind of the demos where we see how DAX works. Any quick questions before we jump on? Going once, going twice. That sounds like a no to me. So let me go walk over to something way simpler. Way simpler. Not that quite yet. Hold on. So let's pop over here, and here I have a very simple PBIX file. Very, very simple, right? How simple is it? It's got 2 tables, and really it only has 1 table. I've got this measures table. That's where I put my measures. I always like to put my measures in a table. It's got 1 column and 0 rows. It's almost like a mailbox in the Cayman Islands or something like that. Measures have to exist on a table, so I create this dummy table to house them, right? The real table, and I say real in quotation marks, is this sales table right here. And here I've got 1, 2, 3, 4, 5, 6, 7 transactions and a very small number of columns. So I've got some sales data for a restaurant, fictional restaurant. I've got the shift something happened in, the type of a transaction, was it to go or dine in? What did the person buy? Was it a pasta? Was it burger? Was it salad? How many did they buy? This person bought 2 orders of pasta. This person bought 1 hamburger. And I have the price for each one. And we're going to use this to sort of see how DAX works, okay? So I've got this physical table in the data model, and if I've got a bunch of visuals up here, every single visual is a rendering of a summarization given to us by the DAX engine. So if I've got this where I've got my total units measure, I click on this, I've got my total units measure broken down by type, right? Well, that's a rendering of a summary table that might look something like this, where I've got total units broken down by type. If I've got average units broken down by type in this column chart over here, well, that's a rendering of this summary table right here, right? So how hard is it to create these visuals? Well, it's very, very easy. Very, very easy, right? So if I want a visual that's got total sales broken down by shift, I go get my total sales measure, I drag it into values, and I get my shift column and I drag that into the axis. That's how I create that visual right there. Fine, that's good. And I can even look at the definition of the measure, right? If you've been doing DAX for a while, this makes a lot of sense. But if you're new, this doesn't really make any sense. What does all this stuff do? How do I get from here to here other than dragging and dropping? Well, let's go look at how we actually build out some of these summary tables, And I'm going to show it to you in Excel because, frankly, it's a pretty good place to sort of imagine how some of this stuff works, okay? So here's the hard stuff, right? So let's say that I want to create a summary table that has total sales broken down by shift and dinner. So this is, if I come back here, basically I want to create this summary table right here so that I can draw this visual. Okay. Come on. Where did Excel go? There we go. Okay. So in order to create this visual, right, focus now here on just this sort of middle band, just this middle band. Power BI is going to issue a summary query that looks something like this. In the reality, it's a bit more complicated. I've tried to simplify it a little bit just so you can see what's going on, right? So what we're going to do is we're going to get all the values of the shift column, which includes both lunch and dinner, because there's 2 shifts at our restaurant, lunch and dinner, and we're going to add a column to it. So we're going to take this temp table is what it is and add a column to it. The name of that new column is going to be total sales, and the definition for it is go use the total sales measure that we've defined that I showed you a second ago, right? So what happens is, just like we asked, right, DAX says, I know how to interpret this. It gets this temp table that's got lunch and dinner, and it adds a column to it with the name of total sales, and it's going to run the total sales measure for each row to go get the numbers, right? So for the top one, it runs the total sales measure and gets 57 bucks. Then for the bottom one, it runs the total sales measure and it gets 43 bucks, right? Now this becomes this temp table here. This is the result of this query right here. And this is exactly what we need. So DAX says, aha, this is going to be my summary table. Let me repackage this so Power BI can read it. So it repackages it to look kind of like that, right? And then sends it off to Power BI, which Power BI can then draw as, where did it go? As that visual right there. Okay, how does it do it though? Well, I told you to focus down here because you're probably overwhelmed with all the stuff on this page. There's a reason I've got several examples. I think after we do these a couple times, all the noise on this page will quiet down just a little bit, right? But up here, we've got kind of all of our working pieces, right? So I'm going to start by showing you how we got this total sales here for lunch. Now, before I do, let's walk through what some of these pieces are. First off, this is the summary table that we're going to provide. This is sort of our goal and our target, right? This is the only table in our data model that we care about, the sales table, okay? Down here, we have the filter context. The filter context is the collection of filters that are active at any given moment, right? So why do we care about the filter context? What filters are active? Well, because that's going to change our derivations, right? Now, I know that's kind of a new word. You haven't heard it before, but a derivation is just a way of getting almost like a copy of a physical table of the data model that you can work with. It's not technically a copy, but you can think of it like a copy. I often think of it in my mind as a copy. If you prefer to think of it as a logical copy, that's just fine. But when you're working with data in DAX, you never actually directly work with the physical table. You always work off of these copies or derivations, right? So here are our derivations. Some of them respect the filters. They respect what filters are in place. Other of them do not respect which filters are in place. All right, Brian, I get it, but this might make more sense if I could see an actual filter in place. Okay, good. Let me change the filter context. And I'm going to use the term here, revise, right? So if you think of the filter context like a document, you're always making revisions to it. You're always adding filters and removing filters. So let me revise the filter context and make a change to it. Right now it's empty, right? I'm going to click on a button and change it that way. In reality, you have to use code, but that's going to take way too long. So I'm just going to click on a button. So I'm going to click on lunch here, right? And when I do, filter for lunch gets added to the filter context. So now there's one active filter for shift equals lunch, right? And did you notice in my derivations over here with the respectful derivations, this one where it just says sales, this has got like half the rows it used to. Well, that's because these are just the lunch rows, right? Now, if I click on dinner, now I get just the dinner rows. If I click on pasta, right, that adds a filter for dish equals pasta. I'm getting just the pasta rows. If I click on lunch and to go, well, now there's a filter for shift equals lunch and type equals to go, and I get the lunch and to go rows, right? So whenever I ask for a table by name, I get this sort of copy type thing, which I call a temp table, right? Which is sort of a copy that you could work with, that you could use to go create a number. You can do other stuff with it too, but the main thing you're going to use it for is creating a number, right? But that's not the only derivation that you got. Let me click back on lunch, right? So when I click on lunch, I've revised the filter context to just have a filter for shift equals lunch. Now we just see the lunch rows here if we ask for the sales table. There's a couple other derivations that we care about. mainly we care about the values column derivation. So if you use the values function and you point at a shift, the shift column here, what you'll get is all of the visible shifts. So if I click on lunch, there's only one shift that's visible, right? So if I look here for shift, these are all hidden, they're filtered out. So we have lunch, 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 and lunch. Well, how many distinct values are there in the shift column? Just one, and it's lunch. So if I asked for value sales shift, I would get this temp table right here, right? By contrast, if I ask for value sales dish, I'm saying, what are all the distinct values in the dish column? Well, if we look up here in the dish column with a filter for shift equals lunch, we see pasta burger, pasta burger. Well, why doesn't it say pasta burger, pasta burger? Well, that's because it doesn't contain duplicates, right? So the unique values are pasta and burger. Pasta again and burger again, it's going to ignore those. It's just going to keep the unique values. If I ask for this derivation, this is the temp table I get. Now, there are other derivations that are non-respectful, and I don't mean they're back behind the gym smoking. What I mean is they don't respect the filters that are in place. So if I've got a filter for lunch, and I use the all function to point it at the sales table, I get a very different temp table than if I just ask for sales table by itself. This derivation right here says, go get me all of the rows of the sales table, ignoring whatever filters are in place. It says, I don't care that there's a filter for lunch. Go get me everything, right? If I click on dinner and to go, right? This derivation just looks at the dinner and to go rows, just that one visible row right there. If I ask for all sales, it gives me everything, because that's what this derivation does. It's for when you want to get around whatever filters are in place, right? And it's similar to this values function. There's also another way we could use the all function. And instead of pointing at a table, we point at a column, and it gives us all the distinct values regardless of the filters. So for instance, if I click on lunch, what you will see is here under dish, like we saw before, there's pasta and burger, because that's all that's visible for lunch. But if we were to ignore the filters, one person, only one person, was healthy at dinner and bought a salad, right? So if I click on dinner, you can see that one person who bought a salad, right? If I'm back clicking on lunch, right, this derivation right here won't include a row for salad because there were no salads sold at lunch. If I use this derivation over here, it says ignore the filters. And so it adds this row for salad, okay? So revision is what changes what filters are in the filter context, which changes the visibility against the model, what rows are visible in our data model, right? And then the derivation will use that visibility in the physical table to create these temp tables, almost like copies that we can work with, okay? All right, good. So with that information, let's go see how we actually create this temp table that we want, where we've got total sales broken down by shift, right? So if you remember the summary query, this is the thing that Power BI wrote, said, I want to go get all the visible values of shift. Notice how this right here, let me set the filters back to empty. Notice how this right here looks like that right there. That's not a coincidence. This is a derivation. It says, I want to go get a temp table that has all the values of shift that are visible. And since there's no filters in the filter context when we start out, because there's no slicers or report level filters or anything like that, it produces a temp table that looks like this, which we then pass into the add columns iterator, right? Iterators all work the same. They're all going to add a column to the table and do something with the result. So add columns here is going to take this temp table, add a column to it called total sales, and it's going to have this definition right here. So add column says, here's this temp table. I'm going to add a column to it with the name total sales. And how do I get the number for each row? I'm going to run the total sales measure for that row and for that row. Okay. When I run it for the top, I get $57. That's my total sales for lunch. When I run it for the bottom, I get $43, right? And then when I've got those two numbers, I've got my summary table. Okay, Brian, but you said you were going to tell me how it actually happens. All right, let's look at how we get this $57 right here. Okay. So that's what we're going to consider right here. We're going to go get total sales for the lunch row. Okay, so this is sort of right before this stage in the process. We're going to run total sales for this lunch row, and we're going to try and get $57. Now, here's the definition for our total sales measure. It's right here. It includes a derivation, right? So sales right there, that's a derivation. It's going to go get all the visible rows of sales, and it's going to pass it to the sum x iterator, which is going to add a column to that table and sum up the results. Okay. Now, before I do that, though, the measure is going to say, wait a minute, this is total sales for lunch. Before I run my formula, I need to change the filter so we're just looking at lunch. Because that's one of the jobs of a measure. The measure says, Okay, I need to run this formula just for lunch. So the measure is going to start by revising the filters, adding a filter for the current row. I refer to that as current row filtering. You may have also heard this called context transition. Same idea, same idea. So the total sales measure says, since we're running in this row, I need to add a filter for lunch. Kaboom, it adds a filter for lunch. And now we could just see just the lunch rows in the physical table, which presents these derivations for us over here. Just the lunch stuff, right? Okay, good. So now that the measure has set the filters for the current row of lunch, it can go ahead and run its formula. So the SumX iterator is going to get a temp table, add this column to it, a column with this definition, and then sum up the results. So let's start with just get the table part, what I call derivation. So here on line 3, it says go get all the visible rows of sales. Now, do I get all of the rows of sales? No, 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 no. When you're working in DAX, you only work with these temp tables. So when I ask for sales, I get this derivation right here, the result of the sales derivation. So let me go ahead and make a copy of this. So when DAX asks for sales with this filter in place, what pops out is a temp table that looks like this, right? So this is the temp table produced by line 3 right there. But this isn't useful yet. These are the rows that we want, but we need to process this and turn it into that 57 bucks. Well, that's where SumX comes in. SumX says, this is a temp table. I can add a column to it with this definition, and then I'll sum up the results. So I'm going to put that right here. Now, this column technically doesn't have a name, but I like to call it the expression column with a capital X. Expression because it's based on this expression right here, which is a fancy name for a formula. I capitalized the X because it says SumX. This is the X that we're summing up, okay? So this is going to be the new column that SumX is going to add and then sum up. What's the definition for? For each and every row, multiply that row's units by that row's price. Okay, we can do this. We take units, multiply it by price. I'm going to go ahead, hit enter, and I'm going to select these cells, and I'm going to copy and paste it down. Control D. There we go. So now I evaluated this formula for each and every row of that temp table. And what do I do with the results? I'm going to sum them up because this is SumX. If I used average X, it would average them, but I didn't. I used SumX. I'm going to type in sum right here. And I'm going to do, whoops, got away from me there. And I'm going to do equals sum. Up, up, up. And there we go. And I get 57 bucks. And that is what this measure returns. And so this becomes 57 bucks. And that's how we got that $57 right there. Okay. Let's look at how we got these 43 bucks. Let me empty the filters. Go back to the way they were. So I'm going to scroll down a little bit. Just remember in your head, we're going to run the total sales measure for dinner. Okay, we can do that. And I'll even leave this up so you can compare and contrast. Okay. So we're running total sales in this row right here. So total sales is smart. It knows it needs to run a formula for the row that it's in. It says before I can run this formula, this expression, right, I need to change the filter so that we're looking at dinner. So total sales says, let me change the filters to dinner. Let me revise those filters. So it revises the filter by adding the filter for dinner. Now just the dinner stuff is visible, right? If I were to ask for sales, I would just get the dinner rows, right? If I were to ask what shifts are visible if we're looking at dinner, well, dinner, obviously, right? Okay, good. So total sales goes ahead and revises the filters. So now we're looking at dinner, right? And now it's going to run the exact same formula. The only difference is last time we had a filter for lunch that the measure added. This time we have a filter for dinner, right? So we're going to run that same formula. Go get all the visible rows of sales. Okay, here they are right here. So when I ask for sales, right, it produces a temp table that looks like this, assuming that we've got a filter for dinner. We're just looking at the dinner stuff. Okay, there we go. That's all the dinner rows, right? And now that temp table gets passed into SumX, right? SumX is an iterator. Iterators always work the same way. It's going to add a column to a table and then do something with the results. So the definition of this column is right here. So let me type in EXP. The column doesn't technically have a name. I like to refer to it as the expression column because that's how I think about it. It's a column based on that expression. And the formula for it is for each row, multiply that row's units times that row's price. I can do that. I bet you can too, although it would be hard because you don't have access to my keyboard. Okay, so I go ahead and enter. And let's Control-C to copy that. I'm going to come down here and Control-V to paste it. So I get 18, 11, and 14. So 2 times 9, 1 times 11, 2 times 7. And when I'm all done, what I'm going to do with it? Well, this is the SumX iterator. So it's going to sum this up. If I wanted to average it, I should have used the average X iterator, but I didn't. I used the SumX iterator. So I'm going to type in sum right here. I'm going to do equals sum to sum those up. And what I do, I get 43 bucks, which if you'll remember is the number we're looking for. So that returns $43. So I got my 57, I got my 43. There we go with that. The table is done. DAX is able to take this, package it up so Power BI could use it, and send it to Power BI to get drawn as a visual, not unlike this visual right here. Okay, we'll pause for a second. Anybody got any questions while I'm trying to remember to breathe?
Just a lot of praise being showered upon you in the comments. This is just the way that you're presenting this is so approachable. This is really neat. Thank you.
Well, thank you. I appreciate that. This took me at least 20 minutes to make. Let me tell you, it was a long 20 minutes. Okay. So you guys want to see another example? Would that be fun? Let's go look at another example, shall we? And it's going to be a pretty similar example. Don't worry. We'll do a couple easy ones before we do something a little bit trickier. Okay. So let's pop over and remember what this second example is. This is going to be total units by type. And we're going to render it as a pie chart. But honestly, DAX doesn't really care how you render it. DAX's job is to spit out the summary table. Okay. So we're aiming for total units by type. Let's pop back. Okay. Pop over here, total units by type. And when we do it, now the real summary query is a little more complicated than this, but I'm trying to draw this in a way that I think that's pretty easy to understand, and frankly just says what the summary query is actually doing, right? We're going to perform a derivation where we get all the different types, so it'll produce a temp table that looks like this, and we're going to pass it into the add columns iterator, right? So, it's both a function and an iterator, right? So what's it going to do? Well, it's going to add a column to this temp table. The name of the new column is going to be total units. And the definition for it is go run the total units measure. So it adds a column called total units. And to get the numbers, it runs total units here. And it runs total units there. Up here, it gets 4. Down here, it gets 8, right? So now it's got that new column with total units. Hey, this is exactly what the person asked for, or the language, the program. So it packages this up in a way that Power BI can understand, creates a summary table like this, sends it off to Power BI, and then Power BI then draws it as that pie chart right there. Okay, but how do we get the 4 and how do we get the 8? All right, well, let's think about it. So let's think about running this total units here for this first row for dine-in, right? So we're going to run total units, this measure, in this row. Now, measures are smart. They say, well, I need to run this formula, but I need to run it for this row, right? I don't just want regular old units for everything. I want total units for the row that I'm in, right? Specifically dine-in this case, okay? So the measure is going to add a filter for dine-in. So let's go ahead and do that, right? So the measure adds this filter to the filter context. Type equals dine-in. Suddenly, we're only looking at the dine-in rows, right? Now, we could use these derivations over here, which ignore the filters to get around it. But assuming we use these respectful derivations, we just see the dine-in stuff. We just see all the sales transactions for dine-in. We see how many shifts there were for dine-in. We see what dishes got bought for dine-in. Notice nobody bought a burger for dine-in. That's interesting. Okay. So the measure adds that filter for dine-in, and it says, okay, now that I've revised the filter, set them to the current row, performed current row filtering or context transition, whatever you want to call it, it can then run its formula or its sub-expression, again, whatever you want to call it. A fancy or less fancy name for the same thing, right? So what are we going to do here in the formula now that the filters have been revised and we're looking at dine-in? Go get all the visible rows of sales, pass it into the SumX iterator, which is going to add this column to it, and sum up the results. Let's start by getting that temp table right there. So this is all the visible rows of sales. Not all of them, right? Just the ones that are visible for dine-in. So if I ask for sales, I get a temp table. Control C. That looks like that right there. Okay, good. There's the temp table that results from that derivation right there. But this is only part of what we need. We need to convert this into that number 4 right there. Well, how do we do that? We pass it into the SumX iterator. Iterators process temp tables. Turn them into something useful, like a number 4, right? Useful thing, that number 4. Okay, so it's going to add a column with this definition to it and then sum up the results. The column doesn't really have a name, but I like to call it the expression column. So it's based on that expression right there, or that formula, right? So what is the definition for this? Well, it's even easier. Just go get the units for each row. Okay, I can do that. I do Control C and Control V, right? So for that row, when I get the units, I get 1. For that one, I get 1, then I get 1, and then I get 2, right? And so if you're really good at math, you might be able to do this even faster than me. So I'm now going to sum these up because this is the sum x iterator. If I wanted to take the max, I should have used the max x iterator. If I wanted the median, I should have used the median x iterator. But I used sum x, so this is going to sum them up. Enter, and I get 4, and that's how I get that 4 that we were looking for. And I'm really happy that it's the right number because the demos are way more impressive when I do them correctly. Okay, so we got that 4 right there. Let's see how we get the 8. It's more of the same thing, right? But the more times you see it, the easier it is to start to get a sense of just how simple the whole thing really is, right? It's not intuitive, but it is simple. It is simple. Okay, let's set the filters back. Set the filters back. So now we're going to run total units, right? But we're going to run it for this row right here because we want total units for to go. And the measure is smart, so before it can run its formula, it's going to say, let me change the filters. Let me revise the filters, make a change to them to add a filter for to go. I'm going to click on to go right here, add that filter to go. Up here it was dine-in, now we're looking at to go, right? And with that filter in place, a different subset of the rows are visible. Now we're just looking at to go stuff. Turns out these are the transactions, the sales transactions for to go. We sold stuff for both lunch and dinner for to go, and we sold a pasta and burger, but nobody bought a salad, right? Okay, so these are the derivations that are available to us with that filter in place, or some of them anyways, right? So now the measure can go ahead and run its formula with those new revised filters. So what do we want to do? Go get all the visible rows of sales and pass it into the sum x iterator, which is going to add a column with that definition to it and sum up the results. Let's start with the derivation. Let's go get all the visible rows of sales, right? Again, not all of them, just the visible ones. So this produces a temp table that looks like this. You can think of it as a logical copy if you want to, or just think of it as a copy. That's fine too, right? Okay, so that produces a temp table that looks like this. And now we want to process it. So we send it into the sum x iterator. We say, I want to convert this into a number, right? Well, how do you want to convert it into a number? I want you to add a column with this definition to it and sum up the results. So I like to refer to this as the expression column. It doesn't really have a name. But people ask me, though, hey, what is the sum x? What's the x you're summing up? Oh, it's the x in the expression column right there, right? That helps you use it. If it doesn't, you can ignore it. So what's the formula here? Oh, it's the same as the formula up here. For every single row, get that row's units. And that's it. That's all you got to do. So I get 2 for the first one. And, whoops. I get 1 for the second row, 3 for the third row, and 2 for the fourth row, right? And what do I do with these? Well, this is the sum x iterator. So it's going to sum them up. If I wanted to min them, I should have used the min x iterator. But I didn't. I used sum x. Boom, there we go. And I get 8, which is that 8 right there. And that's how we get the answer. Notice this measure has the exact same formula, but it comes to a different conclusion because the measure added the filter for the current row, also known as context transition or current row filtering, whatever you'd like to call it. Pause again for a quick question.
We did have a discussion in the chat about sum x versus sum, and I believe it was answered, but Michael, do you want to let us know, do you want any further explanation on that from Brian?
No, I'm good. Thanks, Shannon. I was just curious because I've used sum x for when I have to multiply 2 rows together, but if it's a single column, I usually use sum. So I just wasn't sure if there was an advantage over sum versus sum x for like a single column calculation. So, but thank you for the explanations. They were very good here.
Okay, good. That's normally one of my favorite things to explain, but I think everybody did such a good job that I'm going to go ahead and just let it be. If you want to know more, you can watch my Elements of DAX series. All right, that's enough plugs for me. Let's go do one more of these simple ones, then we'll do something with calculate, which is the big scary monster hanging out in the corner, right? It's not that scary. Okay, so let's go get average units by type, right? So what do we want? Well, we want the average number of units by our different types. And by types, we mean to go or dine-in. So when we're all done, we're going to create this column chart with average units by to go or by type. So for to go, we get 2 units. And for dine-in, we get 1.3. Yeah, this restaurant's probably not going to stay in business very long. I agree. But how do we get this summary table right here, right? Well, let's pop back here, right? So the summary query is pretty similar, right? In fact, it's extremely similar, right? Go get all the distinct values of type, right? And that'll produce this temp table right there, right? And then I want you to add a column to it, and the name of that column is going to be average units. And the definition of it is use the average units measure for each and every row, right? So add columns takes this temp table, adds a column to it with the name average units, and runs the average units measure for each row. For the top one, we get 1.33, and for the bottom one, we get 2.0. And that gives us that right there. That is well, I guess technically the technical term for it is the top level temp table, right? The very last thing that gets produced. DAX says, yay, that's exactly what they asked for. I'm going to go ahead and package this thing up into something that Power BI can understand, or for that matter, something that Excel can understand, or something that Tableau can understand. And I'm going to send it off to that tool to get drawn as a visual, right? Okay, so how do we get this 1.3? Well, let's walk through it. So we're running the average units measure here in this row, right? So measures are smart. They say, I don't want to just perform some calculation. I need to do it for the current row. So before I can run this formula or sub-expression, whatever you want to call it, right, I have to add a filter for the current row. So average units adds a filter for type equals dine-in, right? Let's click on type equals dine-in. Good, there we go. The measure revised the filters, made a change to the filters to set a filter for type equals dine-in. Now we're just looking at the dine-in stuff, right? Okay, good. So now that we're looking at the dine-in stuff, we're going to kind of do the same stuff we did before. Go get all the visible rows of sales, right? Then we're going to take that and pass into the average X iterator, which is going to add this column to it and average the results. Now, if you'll notice, this is the exact same expression column definition that we used in the last one. Before we summed it up, now we're averaging it. Let's see how that changes things. Okay, let's start with the temp table. Go get all the visible rows of sales. These ones right here, no. When you ask for a table, you get a temp table, right? With just the stuff that's visible or whatever else you ask for, right? You're always working off of a copy or a logical copy, right? Depending on how you want to think of it. Logical copy is a bit more accurate, but for the most part, it doesn't really matter. Okay, so we're going to go ahead and get that right here. Kaboom, there we go. Okay, so when I ask for sales with this filter in place, it produces this temp table right here. That's the result of that derivation, right? Now we're going to pass it into the average X iterator, which is going to add an expression column with this definition and then average it. This is pretty easy. EXP. If you guys want to call it something else, you can. I like expression column. I like capitalizing that X like it's a Mountain Dew commercial. Okay, for each and every row, we want to go get the units, and that's it. That's all we have to do. Okay, so I get 1 right there, Control C, and Control V. So I get 1, 1, and 2. Good. What am I going to do with the results? Oh, I'm going to sum them up. No. That was a previous example where we summed them up. Before we used sum X, now we're using average X. So instead of summing it, we're going to average it. Arithmetic mean. So I'm going to take the average of these guys right here, and I get 1.33, which, by the way, is the number we were looking for. 1.33. There we go. Let's set the filters back. Okay, so that's how we got that one. Let's go to the bottom one. We'll do it just a smidge faster, right? So now we're running the average units measure in the to-go row. Measures are smart. They know that they need to revise the filters to look at the values of the current row. So before it runs this formula, it's going to say, hey, what do I need to set a filter to? Oh, I got to add a filter for to-go. Let me go revise those filters. Boom, revise the filters. Add a to-go filter. In DAX, filters are tables, not some filters, not most of the filters, all the filters. Filters are always tables, okay? So that filter for type equals to-go, if that's in the filter context, that means this is the stuff that's visible now, right? So now we say, okay, I'm done revising the filter. I've set that filter for the to-go row. Let me go ahead and run this formula. Go get all the visible rows of sales, add that column to it, average the results. Scoop these up here. Control C to copy it. Control V to paste it. Now that is the temp table, the result of line 3 right there. We pass that into the average X iterator, which is going to add this column to it and average the results. EXP. So there's the column right there. Enter. Let's do Control C. Control V to copy it down. If I was really cool, I could have clicked on the fill handle. I'm not that cool, unfortunately. And what do we do with the results? Well, if this were sum X, we'd sum them up. If it were max X, we'd max it. We're not doing any of that. We're going to average it, right? So let's type in AVG right there. Not the software program to keep viruses off your computer, but the average. The average. That function right there. So if I take the average of those, I get 2, which is, by the way, the number that we were looking for. Doing pretty good so far. Haven't made any big mistakes. Makes me happy. So we get 2. So now that we've got 1.33 and 2, right? We've run the measure for each row. We get 1.33 and 2. Add columns returns that temp table. And then DAX says, oh, yeah, that's all I need. Let me package that up so that Power BI can read it and draw it. It does that. It sends it to Power BI. And then Power BI draws it as something like this right here. Or it could be some other visual. Doesn't matter. OK, let me pause before we move over to the calculate ones. Any questions while we're looking at these kind of simply, guys?
Lots of chatter in the chat. And there was a question further up that Ben had posed. Ben, do you want to come off mute and ask that question?
Yes, and I don't know if I'm preempting what's coming later.
Sure.
But I was trying to figure out if we were looking at how many, say, pastas were bought during lunch, than during dinner.
Yep.
Will that calculation also apply at this point, or are you going to look at that later?
Good question. So kind of what you're getting at, I think, right? If I've got a measure, let me pop over, because I think this is sort of what you're talking about. Let's see, do I have this? Let's say I've got a measure called pasta sales, right? I'm breaking it down by dinner and lunch. Well, the filter for dinner that gets introduced automatically, that's not enough. We also have to add a filter for pasta, right? So if this $14, it's not just dinner sales, it's dinner and pasta sales. So we're actually going to use a measure to add a filter. And that's exactly where we're going next. Is
okay,
that cool?
Yes.
Okay, beautiful. All right. So speaking of which, let's go do that, shall we? Now, we're not going to do pasta sales yet. We're going to start with lunch sales for no good reason whatsoever, other than that's just how I did it. Let's go look at lunch sales. Okay, and this one's going to be a little bit bigger, but it's still not too bad. Still not too bad. We're going to introduce calculate, which hopefully I will prove to you is a little scary, but still kind of simple too, right? So lunch sales, I feel like I got this wrong. Is that really 57? How did I get that measure wrong? Hold on. Shift equals lunch. You know what works way better? If you're looking at the right darn measure. I got all this way without any mistakes. I knew it was too good to be true. And I get absolutely nothing. Let's see. Oh. Oh, I bet. Hold on. I see what I did. Breaking this thing down by shit. Let me make sure that you're breaking it down by type. Aha. Okay, let's break this thing down by type. That was my problem. That's an advanced thing I was showing you. I wanted to make sure everybody was paying attention. Is everybody paying attention? Okay, so
yes.
We're here. We're here. We're with you.
Cool. Okay. So we should get $7.50. It turns out almost all of our sales is to go. Nobody likes our restaurant. They all want to leave as quickly as possible, except for these folks. Okay. But that's just for lunch. Maybe for dinner, that's less of a thing. People need to go back to their computers and watch good streams at lunch. Okay, so how do we get that $7.50? Right? Well, the summary query, again, is going to look very darn similar. We're going to go get all the different types, so all distinct values of type that are currently visible, right? That produces a temp table that looks like that. We'll pass it to the add columns iterator, which is going to say, I'm going to add a column to this table. It's going to have that name, lunch sales. And to get it, we're going to run the lunch sales measure for each and every row, right? So we get the temp table. We add a column called lunch sales. Sorry, the font's a little bit small. We then run the lunch sales measure for dine-in. We get $7. And then we run it again for to-go, and we get $50, right? So we've got 7 and 50. That's the result that we need. DAX Engine packages that up and sends it back to Power BI to draw as that handy tree map right there. Okay. So how do we get it? How do we get it? Well, this one's a little bit more involved, but it's still not too bad. Let's consider this $7 right here. So we're running lunch sales for dine-in. Okay. Let me scroll down a little bit too. It's kind of not all going to fit on one screen. Sorry about that. But okay, so we're running lunch sales for the dine-in row. So the lunch sales measure, just like every other measure, it's smart. It says I need to run this formula for the current row that I'm in. So since I'm in a row for type equals dine-in, I need to add a filter for dine-in. So before it runs this formula, it's going to go ahead and filter to lunch. Okay, so now we're just looking at lunch. But we can't do the thing we did before because, I'm sorry, dine-in. Whoops. So all those good things without any mistakes. So the measure has a filter for dine-in, right? And we're looking at dine-in. So now we see all the dine-in stuff. The problem is, though, the name of the measure is lunch sales. So it'd be awfully darn helpful if we just showed the sales for lunch. But we can't do that right now. We've got a filter for dine-in, which is correct. That corresponds to the current row. We have to add a filter for lunch. Well, how are we going to do that? Well, look at the formula. Isn't it obvious that we're going to do that in here? All right, maybe not. So what's going to happen is in this formula, we've got a bit of code, specifically this calculate function, that's going to change the filters once again to add a filter for lunch to get our filters just right. Revise them one more time. Okay. So the lunch sales measure starts running. It says, I've added a filter for dine-in. That's the current row. Now I could go ahead and run my formula. And what's the first thing we hit in the formula? The calculate function. The job of the calculate function is to change the filters and then run some other formula. It says, hey, the filters aren't right. We have to change them one more time before we can run some sub-formula. Okay. So argument 1 of calculate is the thing that we're going to run after we change the filters, right? So this is going to run after we change the filters, which means even though this comes first in terms of argument 1, this is actually the last thing that's going to run. And to help us memorize that, I'm going to freeze this. I'm going to put it in a block of ice, okay? So whenever you see a calculator, if you're new, take that first argument and with your eyeballs, freeze it. Put it in this block of ice. Calculate is going to run this frozen sub-expression after it changes the filters. Argument 2, 3, 4, 5, 100, however many you got, those are how you want to change the filters. We want to add a filter for lunch. So we need to go create a temp table that says shift equals lunch, and then we can add it to the filter context. This bit right here is in charge of creating the temp table. Calculate will then add it as a filter. So let's create that temp table, right? Keeping in mind that this is frozen. We can't run it yet. We're only allowed to run it after we're done changing the filters, revising them, okay? So now we're going to go get all the values of shift. Notice we use the all derivation right here. So this is actually going to ignore any filters that might be in place, right? So we get all sales shift, which is both lunch and dinner. Control C to copy that. That produces that temp table right there, right? That's both shifts, right? Both shifts, right? Now, that's not what we want. We want a temp table that just says lunch. Okay, well, that's where the filter iterator comes in. Filter is going to take this temp table, the temp table that comes out of this derivation, add a column to it that looks like this, and just keep the true rows, right? So with SumX, it adds a column like this and then sums it up. Filter should be called filter X because it's going to add a column like this and just keep the true rows. Let's see it. So I'm going to type in EXP. It's expression column, just like with SumX. And this time the formula is check to see if each row's shift is equal to lunch. Does that equal lunch? Who majored in logic in college? Does lunch equal lunch? Yes, it does. True. Control C, Control V. How about dinner? Well, sometimes in my house it does. But here in this data model, dinner does not equal lunch. So we get a true and a false. So what does filter do with this expression column? It's going to create a new temp table with just the true rows. So it'll produce a temp table that looks like this. Shift, lunch. Okay? So the all part, that derivation produces the temp table. We passed into filter, which adds this column, which lets us figure out which rows we want to keep. And then filter keeps those rows. That's the new temp table that's produced. So this is argument 2 of calculate. So calculate's going to say, this temp table, I know exactly what to do with it. I'm going to add it to the filter context. I'm going to revise the filters one more time. So right now we've got a filter for type equals dine-in. So calculate's going to revise it again and add a filter for shift equals lunch. So we should be looking at lunch dine-in. Let's say lunch dine-in. Boom, adds that filter, right? So before we were just looking at dine-in, calculate added that lunch filter. So now we're just looking at lunch and dine-in. Calculate has revised the filters again, right? And now we've got the filters just the way we want them, because if you look at the name of the measure, lunch sales in the dine-in row, oh yeah, it should probably be dine-in lunch. Cool, the filters are good. Let's unfreeze this sub-expression and run it. Well, we're going to unfreeze this. It's going to leave a little puddle behind it just to remind ourselves that it used to be frozen, right? So this is the last thing that runs. What do we do here? Oh, we've seen this before. Go get all the visible rows of sales, add this column to it, sum up the results. So now the sales derivation is pretty small, so it's a very small restaurant. Control V to paste, right? And now we pass into the SumX iterator, which adds a column with this definition and sums up the results. Type in EXP. So we get for each row, we multiply the units. times the price. I probably could have done that in my head. I get $7, and I certainly could have done this in my head. But we're going to think the way DAX thinks. It's going to sum up that column. What does it get? $7. And that's how we get that $7 right there. Okay. I'm going to pause for just a second before I do the next row. Any quick questions?
Yeah, Brian, one thing here. I might have missed something there. Why did you do in the filter down there, all cell, yeah, that line, why didn't the line underneath that take care of filtering just for lunch?
So there's a short answer and a long answer, right? The short answer is you can write calculate, and you could get rid of this line, get rid of this line, and get rid of that line. And you could just say calculate this, shift equals lunch, which is probably how a lot of books introduce it. You've probably seen that before. The short answer is when you write that version, it's actually a shortcut way of writing this. So when you write, if I just write, I guess I'll do it. Let me just do it in Notepad, right? Just so you can see it, right? I think maybe this will clear it up a little bit. Assuming Notepad can open. Gosh, things are slow. All right, so let's say you write a measure that looks like this. I'll even simplify it a little bit, right? Something I could spell calculate. There we go. 1, 2, 3, 4. And let's do, well, I'll even make it really easy. I'll cheat. I'll do the sum version, right? So let's pretend there's an amount column in there. And you could do something like this. Sales shift equals lunch, right? You've probably seen something like that before. Is that kind of your question? Why not just write it like this?
Yeah.
Cool, good. That's a great question, right? This is what they call syntactic sugar, right? Which is to say it's a way of writing DAX that is designed to make it easier to look at, but in doing so, it hides the mechanics, right? So if you look at this, the business idea is there. We're setting a filter for shift equals lunch, right? Mm-hmm. But the way that it actually creates a filter for shift equals lunch is internally, it rewrites this as this.
Oh, okay.
So the very first thing it does when it encounters that is it says, oh yeah, it's those humans writing in shorthand again. Let me go fix it for them, right? Now, if you're using DAX, like I'll use the word casually, that's probably not the appropriate word. If you use DAX, I don't know, once a month or something like that, go ahead and use this version, make your life easier, right? You're not going to write complex DAX anyways, no big deal. If you're trying to understand how DAX works, it's important to understand that this bit of code right here actually includes a derivation and a call to the filter function, right? So this is the mechanical representation of sort of this shortcut way of writing it. They both work, but they also both do the exact same thing. Here you can see what it's doing. Here you can see what you're asking for, but not really what mechanically you're requesting. Does that help a little bit?
It does, but I don't think I would have ever caught that on my own.
Took me years. Took me absolutely years, right? There's a couple instances of that, right? The funny thing about DAX is the more you do it, the fewer rules you realize there are. So when you start, you're going to create this big army of rules for all these different ways that DAX works. And then you're like, well, wait a minute, rules 6, 24, and 19 are the same rule. They collapse. Then you find out these other rules are the same rule, and they collapse. Collapse, 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 and you end up with that circle that I showed you a while back. Yeah. It really is pretty simple. Not easy, but simple.
Thanks for that. Appreciate it.
Yeah, sure. Are you guys ready to go see row number 2 in here? Because if you're not, that's too bad. We're going to do it. I think we're good on time. Pretty good so far. Okay, so let's set this back. Let me set the filters back. Okay. So now we're going to run lunch sales, same as before. It's the same exact measure, but we're going to run it in this row because we're looking for to-go stuff now, right? So hopefully we get a different number, right? Okay, so let's think through how this thing works. So the lunch sales measure, when it runs, it's smart enough to know I need to add a filter for the current row because if I don't do it, I'm going to get everything, right? I'm going to get all types. I need to look at just to-go stuff because That's what makes sense. So the measure is going to start by revising the filters before it ever starts to run its formula or its sub-expression, whatever you want to call it. Okay. So it says, all right, I'm running in this to-go row. Let me start by adding a filter for to-go. Revise the filters that way. Boom. Now we're looking at type equals to-go. That's all the stuff that's visible, just the to-go stuff. But wait a minute. The name of this measure is lunch sales. That's not sufficient. We need a filter for to-go and lunch. Hey, don't worry. The formula is going to take care of that, right? So the lunch sales measure starts evaluating. The very first thing you run into is this calculate, which basically says right off the bat, these default filters are not correct. We need to add a filter for lunch because the name of the dumb measure is lunch sales. It's not going to work very good if we don't have a filter for lunch in there, right? Okay, so whenever you see calculate, you should, with your eyeballs, freeze the first argument. Put it in a block of ice. The reason we're going to put it in a block of ice is it's the thing that's going to run very last, right? It's only going to run after we change the filters. So argument 1 right here, this is what we want to do after we get the filters correct by adding one for lunch. That way we can get lunch sales for to go. Okay, so this is what we're going to do after we change the filters, after we revise the filters. How are we going to revise them? Well, that's where argument 2 comes in, right? So we're going to build a filter. It's going to look exactly like the one we did a second ago. That's going to have a 1 row, 1 column temp table. It should say shift, and then underneath it, it should say lunch, because that's the filter that we want. So here's how we get it. We start with this derivation right here. Go get all the values of shift, visible or not. Visible or not. Let's go Control-C to copy those. Drop them right there. Boom, there we go. Hey, that's not what we want. We just want the lunch row. Hey, don't worry. The filter iterator is going to take care of that. So the temp table produces lunch and dinner. We pass that into filter where we say add an expression column with this definition. For every row, check to see if that row's shift is equal to lunch. So we'll do that right here. So I'm going to type in EXP. And here, for every single row, check to see if that row's shift is equal to the text string lunch. I get a true for lunch, and I get a false for dinner still, because things still make sense. Okay, so what does filter do with it? Well, if it were SumX, it would be very confused. This is the filter iterator. It's going to keep the true rows. So it's not going to keep dinner, but it will keep lunch. So filter is going to spit out a temp table. It looks like this. There we go. Shift equals lunch. And so that is the result of lines 9 through 12 right there, this whole block. Calculate takes one look at that and says, oh, I know what to do with that. Let me add that as a filter. So right now, we're looking at type equals to go. Let me add a filter for shift equals lunch. So it should be lunch to go. So boom, it's just going to go ahead and add that filter. There we go. We added that filter for lunch. Now we're looking at lunch to go, right? Which, if you think about it from a business point of view, that should be what's in place for this cell right here. So the filters are right where we need them. So calculate is done revising the filters. Let's go ahead and unfreeze this big block of ice. So with the filters in place, we can unfreeze the sub-expression and run it. There we go. Okay, so what do we do with the filters in place? Same old boring stuff. Go get all the visible rows of sales, add this column to it. We're going to multiply the units times the price for each row, and then sum up the results. Okay, let's start with the derivation. Go get all the visible rows of sales. These ones here, no. We always work off of derivations or copies. Let's go scoop these up right here. Control-C, Control-V to paste. Okay, so that's the result of line 5 right there. Spits out that temp table. But we need to pull a number out of this thing. So how are we going to do that? We pass it to the SumX iterator, which is going to add this column to it. For every single row, multiply the units times the price. I can do that. So we're going to take units times price, enter, Control-C, come down here, Control-V. So 2 times 7 is 14, 1 times 9 is 9, 3 times 9 is 27. What do we do with the results? Well, this is the SumX iterator. So, of course, we are going to sum up that new expression column. Why don't we name the expression column? Well, because it's not going to be around very long. It's going to be around just long enough to get us a number, 50 bucks. So that's how we get those 50 bucks right there, which, by the way, other than the font being a little bit small, is the exact number we were looking for. So we got the 7 bucks, we got the 50 bucks. That produces the temp table right there. DAX says, oh, yeah, that's exactly what I need. Let me package that up so Power BI can read it and draw it. It does so and sends it to Power BI. And then Power BI draws it, not as Notepad, but as that visual right there. We pause for questions. How are we doing on time, by the way? I can't remember when this thing's supposed to go to.
You are welcome to keep going. We usually end around 7:30, but it's
Okay.
this
Keep
is
going.
super valuable, and I don't think there's
Yeah.
anyone here that doesn't want to continue learning from you.
Okay, fabulous.
Keep going.
Okay, I'll do one more of these guys, and then I'll pause for questions. And if people really want to hang around, I got one more trick up my sleeve I could show you. It may be underwhelming at the very end. It's kind of a cool down, but let me do one more. So this is actually the one that was asked for a minute ago, pasta sales, right? So I want a measure that delivers pasta sales, and I want to do it by shift because what I really want to do is create this. I don't know why I'm doing this as a line chart. That's a terrible idea. But for whatever reason, I want this line chart where I can see that our sales, our pasta sales drop when we go to dinner. Oh my God, look at that precipitous drop. Okay, so in order to draw this line chart, we need a summary table with pasta sales broken down by dinner and lunch. So this isn't just sales for dinner and lunch, it's pasta sales for dinner and lunch. So we should always add that filter for pasta. Okay, so I'm here on the pasta sales tab, right? How do we do it? Well, the summary query is going to look something like this. It'll look a little bit different, but this is probably it's a very good approximation, right? It describes what's going on, right? So we get all the values of the shift column, which include both lunch and dinner, because we don't serve breakfast at this restaurant. Maybe we should. We might make more than $100 in a day. So we get lunch and dinner, right? That's the temp table that's produced by the derivation on line 3 right there. That gets passed to the add columns function, which is an iterator, right? It's going to add a column to this table. The column's actually going to have a name. It's going to be called pasta sales. And the formula for it is go around the pasta sales measure for each and every row. So it adds a column called pasta sales, and to get the numbers, it's going to run the pasta sales measure for that row and for that row. For the top one, we get 21 bucks, and for the bottom one, we get 14 bucks, right? Once we've got those numbers, DAX can package it up and send it back to Power BI so that it can get drawn. All right, but how do we get the 21 bucks and the $14? Well, let's look at it. Let's look at it. Boop, boop, boop. Okay, so we're going to run pasta sales for the lunch row, right? And measures are smart, right? They're revisers. So before they run their code, they're going to change the filters to add a filter for the current row. You could call this current row filtering if you want to. If you want to be fancy, you could call it context transition. It's the same idea. If you get into sort of the advanced stuff, there's good reasons that they call it context transition. That is a very accurate name from a mechanical point of view. But if you're new, current row filtering is just fine. Whichever one you want to call it, it's the same idea. But the idea is, right, you take the value of the current row and you add it as a filter. Because we're looking at lunch right here, the value of the current row is shift equals lunch. So before we run this formula, let's add a filter for shift equals lunch. Boom. The measure goes ahead and adds a formula for shift equals lunch. Now we're just looking at the lunch stuff. Okay, good. So that's all fine and good. Let's go ahead and start running that formula. And as soon as we do, the very first thing we run into is another reviser. It says, hold on a second. The default filters aren't going to cut it. So the filter for lunch is insufficient. The name of this measure is pasta sales. You need to always add a filter for pasta. So calculate is going to change the filters before it runs this bit of code right here. So this is calculate's sub-expression. It's the formula that's going to run after calculate changes the filters. So this happens last. So to help us remember that, let's freeze this in a big block of ice. Or a medium block of ice. There we go. So that's our expression. It's frozen. It's only going to run after calculate changes the filters. How do you want to change the filters? Well, that's where this stuff comes in, right? Now we know that the name of the measure is pasta sales. So what we're looking for is a one row, one column temp table that should have the name of dish for the column and the value of pasta, right? That's what we're going towards. But we have to go about it in a sort of circuitous route, right? So we're going to start by getting all of the dishes, right? So let's go get all the dishes, all sales dish, all the values of dish, visible or not. Control C. That derivation produces a temp table that looks like that. You can think of it as a copy if you want to. If you can think of a logical copy, if you prefer that definition, whichever sticks, right? So we go get a temp table that looks like that has all the dishes, pasta, burger, and salad. But we don't want to keep all of these. We just want to keep the pasta one. That's where the filter iterator comes in, right? Should be called filter X because it's an iterator, just like sum X, right? So it's going to take this temp table right there, add a column to it, and just keep the true rows. The definition of the column is dish equals pasta. Let's type in EXP up here. So for each and every row, we're going to see if that row's dish is equal to pasta, right? So does pasta equal pasta? Last time I checked, it certainly does. Does burger equal pasta? It does not. Does salad equal pasta? God, I wish it did. It does not. We get a false, right? So what is filter going to do with this new column? It's going to keep the true rows, which means it's going to get rid of salad, it's going to get rid of burger, and it's going to keep pasta. So filter spits out a temp table that looks like that. Hey, you know what would look really cool is if we took this temp table and added to the filter context. It would be cool. That's exactly what Calculate's going to do. When you hand calculate a temp table, it assumes that what you want to do with it is add it to the filter context. That's why Calculate exists. That's almost everything that Calculate does, is just add filters to the filter context. Okay, so Calculate is going to add this filter for dish equals pasta. Right now we're looking at shift equals lunch. We're going to add dish equals pasta. So we should be looking at lunch pasta. Sounds like a fun plan to me. Lunch and pasta. So let me click on that, revise the filters. Calculate revises the filter again to add that filter for dish equals pasta. Now we're just looking at this stuff over here. This is what's visible. This is what's visible in the data model. This is the stuff we can get. So what do we do with that? Well, now that the filters are correct, they're the way that we want them, right? Calculate's done revising the filters. It's going to go ahead and unfreeze its sub-expression and run it. Let's unfreeze that. There we go. Okay, there's a little puddle underneath it. This is the thing that happens after we revise the filters, after Calculate revises the filters. So what are we going to do now? We're going to go get all the visible rows of sales, add that column to it, and sum up the results. So let's go get all the visible rows of sales. There we go. There's that derivation right there, right? But that's not enough. We need to turn this into a number. That's where the SumX iterator comes in. Iterators process temp tables, squeeze a number out of it, right? So SumX is going to add this column to it and sum up the results. So let's go add my EXP column. Doesn't really have a name. I like to call it the expression column because it's based on the expression in argument 2. For each and every row, multiply the units times the price. Times the price. I get 14. 2 times 7 is 14. And 1 times 7 is 7. Who's good at math? We sum that up. And I get $21. 21 buckaroos, which is, by the way, other than the formatting being a little off here, let me convert that to dollars right there. The exact number that we wanted, 21 bucks. How about that? Okay, let's go ahead and do it for the bottom row. Bottom row. Okay. So now we're going to run the pasta sales measure for this row. Measures are smart, right? And so they know I need to run this formula. I need to run it for the current row that I'm in. I need to revise the filters before I run my formula. Otherwise, the number is going to be wrong. So pasta sales says, let me add a filter for dinner. Pasta sales adds that filter for dinner. Very good. Okay. So now with the filter for dinner in place, we're just looking at the dinner stuff. The formula starts running. And the first thing we run into the formula is, hey, wait a minute. We need to change the filters again. The name of this measure is pasta sales. We don't have any filters for pasta. That's no good. We got to add one. So before you do this stuff, add a filter for pasta. So Calculate is going to add some filters and then run sort of a sub-formula, if you will, or a sub-expression. So let me go ahead. Let's freeze this. This is the thing that happens after we change the filters. Okay. Okay, good. Now that's frozen. A big block of ice, which I could really use. My office just climbed about 20 degrees in the last 45 minutes. So we've got this block of ice where the formula is. This will run after we revise the filters. We want to add a filter for pasta because the name of the measure is pasta sales. How do we do that? Right? Again, we're going to use a derivation and an iterator, just like before. So we're going to derive all the values of dish over here. Control-C to copy it. Control-V to paste. Okay, so line 10 produces this temp table right here. Wait a minute, that's not what we want. We just want the pasta row. All right, so if we need to whittle down a table, we use the filter iterator, right? Which is going to add a column, which is however we define it, and it'll keep all the true rows. So I'm going to do EXP. Column doesn't really have a name. I like to call it my expression column because it's based on that expression or formula right there. So for each and every row, go check to see if that row's dish is equal to pasta. Boom. So pasta equals pasta. That's true. Burger does not, and salad does not still, unfortunately. Okay. So what does filter do with this? It's just going to keep the true rows. So it's going to get rid of salad, it's going to get rid of burger, and it's going to keep pasta. Produces a temp table that looks like that right there. Okay. So lines 9 through 12 produce this temp table, and like the filter kind of hands it to Calculate, says, I don't know what you want to do with this. Calculate says, oh, I know exactly what I want to do with it. Whenever you hand calculate a temp table, it loves to add it to the filter context. So that's what it's going to do. It's going to add this temp table to the filter context so that it can run its sub-expression with the filters just right. So right now we're looking for dinner. We want to be looking at dinner and pasta. Let's go find dinner and pasta. Very romantic. There we go. So now calculate has revised the filters again. The measure added the first filter for dinner. Then calculate added that filter for pasta. Revise once, revise twice. Now the filters are just right. We can unfreeze this sub-expression and run it. Last thing that runs is calculate, or argument 1 of calculate. Okay, so with the filters just right, we unfreeze that. And we say, what do we want to do? Go get all the visible rows of sales, add that column to it, sum up the results. You guys know this song and dance. Control C, Control V right there. The derivation on line 5 produces that temp table right there, right? Sum X is going to add that column to it and sum up the results. So for each and every row, which is just the one row, take the number of units and multiply it by the price, right? So that's what we get for each and every row, which is just the one, and then we sum it up because it is the sum X function after all. So if I sum up that one value, you may not be surprised to find out that the answer is 14. 14 right there, which is the answer, although somewhat teeny tiny. Let's see if I can make that font a little bit bigger. Come on. Oh, Excel's stuck. Excel's angry. There we go. 21, and let's make it a number. There we go. Okay, it's still the wrong size, but it's the right number, which is what I really care about. Okay. So we've done sort of 3 of the easy examples where we don't have to change the filters. We've also done 2 examples where you can see that the purpose of the calculate function is to change the filters. Whatever the default filters are for a measure for the current row aren't sufficient. We have to change it further. So calculate's going to have some sub-expression, a thing that it's going to run after it changes the filters, and then it's going to have multiple arguments that define how you want to change the filters. So that's really all calculate does. Okay. So I'll probably pop over to questions right now. If people really want to stick around, I can show you one more kind of easy example. But before I do, I know it's getting late out there. Let me pause. Who's got questions? I'll even go to my self-promotion slide before I do. I'd get in trouble if I didn't shamelessly promote myself. Hey, look, it's a picture of me. I'm even wearing a hat this time.
We still have quite a few people on the line, so y'all feel free to unmute yourself if you have questions.
I have a question.
Yes.
Hi, Brian. Can you go back to the Excel?
Okay.
Yeah.
Monster?
So I am new to DAX.
Sure.
So if I just think by myself as for how to calculate the dinner and to go, I'm thinking I need to use 2 filters. So I'm thinking in my mind, I need to have 2 filter formula underneath the sum X. So in my mind, I'm like, okay, do the first filter just for lunch, the second filter for the dish, or for the pasta, sorry. But here, this is your formula only has 1 filter for pasta. So if I just look at this, I'll be like, so where's the lunch part filter?
Good, very good question. That's part of what makes DAX a very difficult language, right? So let me pop over to Power BI and maybe illustrate why it has to be confusing, right? So let's start with what we have, which is, it was pasta sales, right? Let's go get that. So we got pasta sales. Let me add it as a table, right? And so it was pasta sales broken down by, what was it? By shift, right? So, okay, so that's tiny. Let me make the font a little bit bigger so you can see it. All right, that's pretty good. Okay. So now here we've got pasta sales broken down by dinner and lunch, right? And so in the measure, right, for pasta sales, you can see the filter for pasta, but there's no explicit filter for dinner or lunch, right? Now I could create a measure called pasta dinner sales and another one called pasta lunch sales. The problem is I would have to have 2 separate columns. And furthermore, what if tomorrow I want to break down pasta sales not by shift? Here, let me copy this. I don't want pasta sales broken down by shift. I want it broken down by type, right? So now that same formula has to be smart enough to, oh, interesting. I got the same number. That's wild. So that same number, that same measure has to be able to add a current row filter for dinner and for lunch. But then over here on a different visual, it has to add a filter for dine-in or to go. So the tricky thing about this is you don't know ahead of time what filters are going to be needed for a measure, because from visual to visual to visual, you're going to have different current row filters that have to be added. So when you write your measure, you add the explicit filters you need to. So for pasta sales, we're always going to add a filter for pasta, but I might break down pasta sales by shift. I might break it down by type. I might break it down by units. I'm not sure why I would, but I could, right? So that's the tricky thing about it, is it is a non-explicit language. So there are going to be filters that get added that you can't see in your measure because you won't know ahead of time what those filters are going to be, because they're going to be different from one visual to the next, right? So it's a very good question, but it just leads to why DAX is difficult to learn and difficult to write, because when you're writing the measure, you won't know where it's going to be used. Or more specifically, you know that it's going to be used in multiple places, so it has to work in a generalized way. Does that answer the question a little bit, or maybe dodge it successfully?
A little bit, but how does DAX know that it's going to be filtered for lunch as well?
Good. Yeah. Okay. So so we come up here to this one here, so we can see both the summary query and this first number right here, right? So one of the behaviors of a measure is it's always going to, before it runs its formula, look and see, are there any values of the current row? And if there are, it will add them as filters, right? So even though it's not written explicitly, when I call a measure as part of a row, before it runs the formula, it will always add the filters for the current row. So here it adds it for lunch and for dinner. If I had a different summary query where it was breaking it down by type, it would add it for the different types. So whenever you call a measure, it is always going to perform current row filtering or context transition, which is, it's one of those things that frankly you just have to remember. You could see, like, based on your question, you could start to see why it's required, right? If it didn't add that filter, it would get the wrong answer. It needs to add a filter for the current row, but I don't know what's going to be in the current row because it might change from visual to visual. That's why the behavior is, whenever you call a measure, before it runs the formula, it always adds the value for the current row. But this could be different from visual to visual.
But how does the measure know which one's the current row? Because how, like in this formula, how did you tell the DAX to look at shift instead of type?
Yep. Okay, so let me set this number back here. So I define the measure ahead of time in the data model, right? This formula is being called as part of this summary query, right? So these are not isolated, right? So when I run pasta sales, it's running it for that row. I'm specifically saying run pasta sales for that row, then run pasta sales for that row. That's part of my definition here. I say go get the two shifts, lunch and dinner, and for each one, run the pasta sales measure. So because I'm asking for a measure, the measure says before I could do anything else, I have to look and see what current row am I in, and then add filters accordingly, right? So I'll pause. Does that help a little bit?
I kind of getting there, but I'm not specific, very clear.
Yeah, no, that's fair. And it's confusing, right? So let me go, I'm here in DAX Studio, and let me go pull this out. If somebody has an open mic, by the way, it isn't a big deal, but a lot of times people don't want to have the open mic. So here I am in DAX Studio. DAX Studio is a third-party tool. It's a great one, by the way. It lets you actually go run summary queries, right? So I could take a DAX query like this, and I can run it, and I could get the results, right? 21 and 14. Okay, so notice the pasta sales measure, right? I'm asking to run it for both that row and that row. So before it runs the formula for pasta sales, it adds a filter. It knows because it's part of this query right here. The formula doesn't run in isolation. It runs as part of this row and then as part of that row. Now I could take this same thing and say, you know what, I'm tired of breaking this thing down by shift. I want to break it down by type. Right? And now I run this, right? And I get different results, right? Now it knows to add a filter for to go for this row, and it knows to add a filter for dine in for this row, because I'm running the measure as part of this summary query right here. When you define a formula in Power BI and DAX, right, you're defining a basically a formula that's going to get used as part of a larger formula. So you write pasta sales, but it might get used in this summary query, or it might get used in this summary query. Because of that, one of the behaviors of a measure is it will always look when it runs, and before it does its formula, it adds a filter for lunch and dinner, right? Or it adds a filter for to go for that row, and then dine in for that row. So the measure is smart enough because it's being run as part of this larger query to know that I'm being asked to run row by row by row. So when I run for each row, I go find the values of that current row and I add them as filters. That's just part of the default behavior. You couldn't attend it ahead. You couldn't define it ahead of time because it'll be different from visual to visual. Helping some?
Sorry.
No worries. It's hard. Yeah.
I understand now that it's referring to a row, but how does the formula know is I want to refer to the lunch or I want to refer to go? Where does it tell you on the formula?
So it doesn't because it can't. So in the formula for pasta sales, it needs to be used arbitrarily, right? So it needs to be able to be used in this formula and work, and it needs to be able to be used in this query and work. So because of that, you can't define it in the formula. That's why the behavior is don't ask, right? You don't have to explicitly say it in the formula. It just automatically does it. It's one of the automatic behaviors of the DAX language, which is confusing, but that is how it works.
But why it doesn't calculate like to go by type? Why does it automatically just calculate by the lunch and dinner?
I'm sorry, say again?
So like when it refers to the row,
Yep.
Why it refers to the column of lunch and dinner instead of referring to the row to the column of to go and dine in? How does it know?
It just knows, right? So for this cell right here, it can look to the left essentially and say, I'm being run in this type filter, so I need to add a filter for to go, right? So the formula, runs after the measure changes the filter. So if you look at the formula, the formula is not 100% of what a measure does. It only runs it after it changes the filters. So it's going to run the formula after the filters have been changed. And because I'm running it as part of this, where I say go get all the values of shift, it knows to add it for to go and then dine in. When I run it down here, right, it knows, all right, I'm running it in a to go row, I need to add to go, or it's adding in dine in, I need to add dine in, right? So it is not explicit in the formula, it's just an automatic behavior, right? DAX doesn't ask you if you want to add the current row value as a filter, it requires it. You can't get around it.
So it sounds like it just initially returns everything there. And it's upon the.
It might be helpful since she said she was new. I don't think that this is a DAX issue. Could you go back to the Power BI?
Yeah, sure.
Page?
Which one? This one here?
Yeah, and it's coming from those values in the fields pane. You're specifying you want pasta rolled
okay.
up by type.
Okay,
and so that's where it's getting the list of type. It's because it's what's specified in the visualizations pane.
Yes, thank you. Very good call out. So I could take pasta sales and I could break it down by type if I want to, right? Or I could say, if I were to do that, right, take pasta sales and break it down by type, it's going to write something that looks like that, right? By contrast, if I run, I could take this same thing and say, you know what? I don't want to break pasta sales down by type. I want to break it down by shift. And now Power BI says, okay, based on what they asked for, I need to rewrite the summary query so that it looks like this. So it runs that same measure by shift. Does that help a little bit? Is that sounds?
Yes, I got it. Yeah.
Okay.
Thank you so much.
No worries. It's tricky. It's very tricky. Okay. Other questions out there? I see a couple. I don't know if people want to come off of mute, or I don't know how we want to handle. I don't know. Does somebody just want to jump on mic or something?
Yeah. Let me just take one moment just just to thank everyone for joining, and Brian, to thank you. This has seriously been so incredibly helpful. The way that you break things down and the way that you explain things, it is just really incredibly accessible. So thank you so much.